The important topic, what is the pitch factor, chording factor, coil span factor, all are same, Kp, Kd, Kc, or it is denoted by Kp, Kc, Kd, or pitch factor, distribution factor, or chording factor, coil span factor, all same. What is pitch factor? What is how to define pitch factor is, if the coil span factor Kp or Kc, it is defined as the ratio of vector sum of EMF induced to arithmetic sum of EMF induced per coil. One coil, suppose assume that one coil slide is not one pole, another coil side is another pole. Then if they are distributed equally, then it is full pitch winding, 180 degrees exactly. But we are using fractional slot winding, fractional pitch winding, short pitch winding, short pitched by 30 degrees. 180 by 6 instead of 7, if you use 180 degrees, instead of 6 slots we are using 30 degrees short pitch winding is. What is the pitch factor, chording factor, coil span factor? That is important derivation regarding electrical machines 3 discuss now. Now we are explaining that if the coil span or coil pitch is not equal to pole pitch 180 degrees, then that winding is known as short pitch winding. Chorded winding it is also known as. It is also known as chorded winding. The coil span in short pitch winding is less than 180 degrees. This coil generally shorted by 1 or 2 slots. 1 or 2 slots, generally all the armature windings, armature slots generally shorted by 2 slots, 1 or 2 slots, the coil, because it becomes short pitch winding. Short pitch winding gives more sinusoidal EMF, that's why we are using short pitch windings mostly. In figure 1, in this diagram the coil sides are placed in 1 and 7 instead of then it is a full pitch. 1 and 7, if you place the conductors, it is a full pitch. The dotted line represents if the conductor 7, instead of providing conductor or coil side in this conductor slot 7, providing that 6, it is known as short pitch winding. It is short pitched by at an angle 30 degrees. 180 by 6 slot it is 30 degrees, because 2 poles are responsible for 180 degrees. The advantage of short pitch winding already we discussed. They save in copper connections, because ikkada nunchi ikkadi copper connection ekku avutadi kabatti ikkadike takku avutadi. They improve the waveform generated, more sinusoidal harmonics are eliminated, hysteresis eddy current losses will be reduces, hence efficiency will increases. The pitch factor is defined as, or coil span factor is defined as, or it is a ratio of vector sum of EMF induced in per coil to the arithmetic sum of EMF induced per coil. Let E1 and E2 be the two EMFs induced in two coil sides. The vector sum divided by arithmetic sum gives pitch factor or coil span factor. It is always less than unity. How it is less than unity? It is always less than 1, we can see now. Let ES be the induced EMF of each coil side. If the coils were placed full pitch, that is 2 coil sides are 1 pole pitch 180 degrees, then 2 induced EMF is 2 ES. You can see 180 degrees displacement jarite ikkada nunchi ikkadiki 180 degrees untundi. ES is the EMF induced in one conductor slot, one conductor, one winding, one coil, another coil is 2 ES. Now if it is chorded by angle alpha, then you can see the EMF induced. It is a ES. It is ES EMF induced in one coil side, and another coil side EMF induced is, it is another ES EMF induced. This displaced by at an angle alpha. Now the arithmetic sum, it is the arithmetic sum. It is the, from this triangle we will get vector sum. Short pitch coil, it is the one coil side EMF, another coil side, the resultant is ER. O, A, B, if you consider the triangle, then it is an alpha, that is chorded angle. After that, what is the angle here is alpha by 2. If you draw a line, ఇలా ఒక లైన్ డ్రా చేస్తే ఖచ్చితంగా ఇక్కడ ఆల్ఫా బై 2 యాంగిల్ ఉంటుంది. అంటే సమాంతర రేఖలు ఆర్ ప్యారలల్ లైన్స్ దీస్ ఆర్. ఇఫ్ యూ డ్రా ఎ లైన్ హియర్ ఆల్సో, దిస్ యాంగిల్ విల్ బి alpha by 2. Now the coil is short pitched by an angle alpha, then the 2 EMFs in one coil side is the vector sum of 2 voltages as shown in figure this one. As AC is perpendicular drawn on OB on that AC is drawn perpendicular, then length of OC equal to length of CB, that equal to ER by 2 is. Now angle BOA equal to alpha by 2. You will get angle BOA is alpha by 2, or angle COA also equal to alpha by 2. Angle BOA equal to alpha by 2. Therefore cos of alpha by 2 equal to, if you apply the cos for this triangle, OC by OA you will get, that is OC is known as ER, OA is ES, 2ES. OA is, it is ES only. Now it is cos alpha by 2 OC by OA. OC is known as ER, and ES OA is it is also we have to consider OA, it is known as 2ES. From that resultant voltage ER equal to 2ES cos alpha by 2, that equal to, make it as equation 2. Already ER equal to 2ES, that is the equation 1. ER equal to 2ES, assume that it is equation 1, then ER equal to 2ES cos alpha by 2. From equations 1 and 2, the resultant EMF in short pitch coil is depends on the angle of short pitch or chorded angle alpha. From this, the resultant EMF in this short pitch winding is depends on alpha, the angle of chording angle. Now Kc or Kp, pitch factor or coil span factor, is defined as EMF induced in short pitch winding to EMF induced in full pitch winding. EMF induced in short pitch winding is 2ES cos alpha by 2. EMF induced in full pitch winding is 2ES. If you divide 2ES get cancelled. 2ES we can cancel each other. Now Kc or Kp equal to cos alpha by 2, where alpha is known as chording angle or short pitch angle. This formula is important to do numerical problems on electrical machines 3 or synchronous generators. Now another important topic, which is distribution factor, breadth factor, or winding factor, or spread factor. These are also. Distribution factor, it is KD. Breadth factor or winding factor, spread factor, all are equal. It is also important derivation for a synchronous generator. The coils in one phase of alternator is not concentrated in one slot but are distributed number of slots. The coils అన్నీ ఒకే స్లాట్లో బెటర్ డిస్ట్రిబ్యూట్ చేస్తారు to give more sinusoidal uniform and polar groups under each pole. The distribution of conductors to all slots improves the nature of induced EMF, that is more sinusoidal. That's why we are go for distributed winding instead of concentrated winding. In concentrated type, all coil sides will be placed in one slot and slot angle beta equal to 0 in concentrated winding. In concentrated winding, slot angle beta equal to 0. What is beta? 180 by n. 180 by n, or beta equal to number of slots per pole per phase. Beta equal to 180 by n is known as n. What is pole pitch? After that, number of slots per pole per phase is beta. In distributed winding, the coils are distributed in each poles as shown in figure, like that. The coils are distributed, number of poles, the coils are distributed. If you consider the coil, it is one coil. First the conductor under north pole, after that it is reached to south pole, again it reached to north pole, again it reached to south pole. Like that, if it is distributed, it is known as distributed winding. What is the factor? Distribution factor or breadth factor we have to calculate for synchronous generator. In distributed winding, coil sets are distributed in each poles. The magnitude of induced EMF same in all coils under one pole but having a phase difference beta degrees. Beta is known as slot angle. Beta degrees ఉంటుంది. EMF magnitude same ఉంటుంది, but phase angle beta is phase difference is beta degrees with respect to each other. Now consider 18 slots 2 pole 3 phase alternator. If you consider, for example, Now n number of slots per pole for this n equal to 180 by 2, 9. Similarly, beta equal to 180 by n. 180 by n is 180 by n, 20 degrees. Now the slot angle beta is 20 degrees. 20 degrees EMF will be phase difference between two conductors in case of distributed winding. Now if you consider the same diagram, EFC is induced in one conductor 1, and ES is also EMF induced, because our EMF induced is same but phase angle will be contributed beta degrees. Similarly, phase difference between induced EMFs in these slots is given by like this diagram. Now the resultant, how can you draw? Similarly, previously what we drawn, ES, like n number of conductors are there, it will come around totally 180 degrees, 360 degrees, the total conductors are distributed. You can draw this diagram. It is EMF induced in one conductor, another conductor, n number of conductors, it becomes a closed slot. Now we go for this is the diagram. The same again. What is phase spread? M beta is known as phase spread. In general, there will be n number of slots per pole and m slots per pole per phase. So there will be m coils will be distributed under each pole. For m, EMF induced in phasor diagram. What is m? What is n? You have to know. What is m is number of slots per pole per phase. ఒక పోల్ కింద ఎన్ని స్లాట్స్ ఉంటాయి ఒక పేజ్కి సంబంధించినవి, దట్ ఈస్ ఎం అండ్ ఎన్. నో బీటా ఈస్ ద వాల్యూ ఆఫ్ యాంగులర్ డిస్ప్లేస్మెంట్ ఈఎంఎఫ్ ఇండ్యూస్డ్ ఇన్ ఈచ్ స్లాట్. ఇఫ్ యూ కన్సిడర్ దిస్ ఈస్ వన్ స్లాట్, ద యాంగిల్ బిట్వీన్ టూ కండక్టర్స్ ఈఎంఎఫ్ ఇండ్యూస్డ్ ఈస్ బీటా, స్లాట్ యాంగిల్ ఇట్ ఈస్ ఆల్సో నోన్ యాజ్. బీటా ఈక్వల్ టు 180 by n, that is the beta equal to 180 by n. If n degrees are n is the number of slots per pole, that is pole pitch. If you divide 180 by pole pitch, then you will get beta. Let m equal to number of slots per pole for phase. M beta is known as phase spread. How the each phase is distributed? M beta, that is known as the product of number of slots per pole for phase into slot angle gives phase spread. The phasor diagram m slides, m number of coils. The phasor diagram of m number of coils seems to be a m-sided polygon as shown in this diagram, having radius r is the radius, o a it is the radius r, and ab bc cd are the emf induced. This angle also becomes beta. This represents emf per coil. All the ends are joined to o, which is center of the semicircle of radius r. It is the radius r semicircle. This angle is known as m beta. But half of this angle, one conductor, one slot, it is m beta by 2. This is all triangles are OAB, OBC, OAB, OBC, like that m-sided polygon will come up to. But all induced EMFs are ES only, because in one phase, one slot, under one pole, what are the EMF, what are the conductors? The EMF will be magnitude is ES, but phase difference is beta is the angle. Let angle OAB equal to OBA equal to OBC equal to X. Assume that OAB, this angle is X. Assume that angle OAB, AOB angle is Y. Assume that in triangle OAB, 2X plus Y, this is the angle we assumed, and this is the angle X also, it is Y. Angle OAB, it is angle OAB equal to X. Angle OAB is X. Angle AOB is Y. Assume that. In triangle OAB, this is the triangle OAB. In triangle OAB, 2x plus y equal to 180 degrees. In triangle OAB, 2x plus y equal to 180 degrees. From this phasor diagram, 2x plus y. 2x plus y is known as beta. Y is also known as beta. 180 degrees. From that, y equal to beta, it is. Therefore, from triangle OBA and OBC, we can write y equal to beta. Now angle AOM equal to M beta, that is M beta equal to space spread angle, and AM equal to your resultant EMF. Consider a triangle OAB separately. If you consider OAB, this is the angle beta, you exactly of it is ES by 2, ES by 2 and beta by 2. Length of AB is ES, length of AB is ES, length of A and F is half of this ES, that is ES by 2. Length of OA equal to R, radius of the circle. From this, if you apply the sin theta, sin beta by 2, if you apply the sin theta, then you will get sin beta by 2 equal to AF by OA, that equal to ES by 2 by OA is known as radius R, assume that. From that ES equal to, from that is equation ES equal to 2R sin beta by 2, make it as equation 1. Now considering same triangle, another triangle OAM as shown in figure. Previously what is OAM, triangle OAM we have to consider. OAM we have to consider. OAM, this is the triangle we have to consider. By considering triangle OAM as shown in figure, OF is the perpendicularly drawn OA bisecting OAM. Triangle angle of AOF equal to FOM equal to M beta by 2. This is the phase spread diffusion M beta by 2. Length of AM equal to ER, length of AF equal to ER by 2. For the triangle OAM, if you consider this triangle OAM, for this triangle, if you consider length of AM equal to ER, length of AF equal to ER by 2, sin M beta by 2, if you apply sin theta for that, AF by OA, ER by 2R. Therefore, ER equal to 2R sin M beta by 2. Make it as equation number 2 and this is equation number 1. The resultant EF in coil in distributed. This is the resultant EMF in coils which are distributed. If M coils are concentrated on one sort, the EMFs are in phase is equal to algebraic sum of all EMFs. Concentrated winding, if it is a concentrated winding, ER equal to M into ES 2 MR, that is sin M beta by 2 from equation 1. If it is a concentrated winding, beta is 0. Sin beta is 0, then sin 0 equal to, because 0, the resultant EM well becomes 0. Let us this is the important equation that we have to remember how to derive this. When coils are concentrated, ER equal to 2 MR sin beta by 2, make it as equation 1. What is KD? It is defined as the ratio of distribution factor is defined as ER when coils are distributed, ER when coils are concentrated. Resultant voltage when coils are distributed to concentrated. Now we are substituting two equations, 2R sin M beta by 2 by 2 MR sin beta by 2. If you substitute the equation 2 and 3, you will get KD equal to sin M beta by 2 by M sin beta by 2, where M is number of slots per pole for phase and beta equal to slot angle 180 by N. N is number of slots per pole. This is the important derivation distribution factor KD. KD or breadth factor, it is also known as the value of distribution factor for three-phase alternator for different slots per pole for phase. If you substitute M and beta different slots per pole for phase, now the table you can see, if you substitute M and beta so many values, then how the KD will vary. That is slots per pole N 3, 6, 9, assume that. Slots per 4 for phase is 3 phase, if it 3 by 1, 3 by 3 is 1, 3 by 6 by 3 is 2, like that you will get. Slot angle beta is 180 by N, 180 by 3 is 60 degrees, similarly 180 by 6 is 30 degrees, like that slot angle beta. Distribution factor will changes 1, like this the distribution factor will changes. When beta is very small and M is large, then the total phase spread is M beta. Sin M beta by 2 equal to AC by OA. Phasor sum and vector sum, if you consider phasor sum and vector sum, arithmetic sums of equal to arc of AB, OA into MB, therefore KD equal to OA phasor sum by arithmetic sum, KD equal to sin M beta by 2 by M beta by 2, where M beta by 2 is in radians. The above formula used to calculate KD when M beta and winding is uniformly distributed. For uniformly distributed, this formula is.